Hello everyone. Today we will be discussing whether a site can be determined to find carbonaceous chondrites in the Antarctic. Hidden in the cold Antarctic desert, Ansmet meteorites are able to help us understand planetary and asteroid formation. Specifically, carbonaceous chondrites are able to provide hinted information toward the delivery of water to Earth and the early history of the solar system. Considering the importance of these chondrites, we have investigated whether a site in the Antarctic can be determined to a guaranteed find of carbonaceous chondrites. Through accessing the Ansmet database, we isolated carbonaceous chondrites data, measuring how many chondrites per location. With data that informed of areas with a high percentage and lower percentage of carbonaceous chondrites, conclusions were drawn regarding whether there are determined sites to find such meteorites.
Ansmet stands for the Antarctic Search for Meteorites. It is a program funded by the Office of Polar Programs of the National Science Foundation that looks for meteorites in the Trans-Antarctic Mountains. Carbonaceous chondrites, stony meteorites, are the most common type of meteorite. They are made of rock, but also contain small amounts of iron.
So on the right here we have a bar graph depicting the number of total carbonaceous chondrites that's found at each site. On the left we have a map depicting where each site is in Antarctica.
We found that of the 963 carbonaceous chondrites recovered by the U.S. Ansmet team, most were recovered in just a few select sites, those being the Miller Range, the Elephant Moraine, Allen Hills, La Paz Ice Field, Queen Alexandra Range, Dominion Range, and a handful of others. Most sites, however, had few or no carbonaceous chondrites recovered. 12 had less than 1% of the total carbonaceous chondrites recovered, and another 26 sites had none.
Based on our research, there is no concrete method to determine the objective best site to find a meteorite. However, we can recommend sites where scientists might have a higher chance of finding meteorites. Assuming that all meteorites fall randomly, then there is a higher possibility of finding a meteorite in areas where few were found before. However, we know that ice flows towards the ocean, so there is a higher chance of finding a meteorite in areas closer to the sea. Additionally, the ice flow would collect all the meteorites into one location. Therefore, we recommend that scientists search for meteorites in the sites DAV, EET, ALH, DEW, and the surrounding areas. EET and ALH have a high percentage of meteorites, suggesting that an ice flow deposited the meteorites into that location. The lack of meteorites found in DAV and DEW suggest a possibility that there are undiscovered meteorites in those sites.
Finally, based on data provided, we believe that future Ansmet missions that are looking for carbonaceous chondrites should go to the following sites: David Glacier, Elephant Moraine, Allen Hills, and Mount DeWitt. These sites are located near the end of the ice sheet, where debris and meteorites are released from. Because of this, these sites are the best to look for carbonaceous chondrites. Some of the best features of this internship were that we as a team got to use real data provided by the ARIES program, and that we got to work with people from around the United States and help one another. Some of our hardest challenges were researching, understanding, and interpreting complex data compared to our previous research experience. Finally, we would like to thank Margaret Baugio, Selena Miller, NASA Texas Space Grant Consortium, Kelly Bundle, Suzanne Foxworth, all the NASA ARIES speakers, and all the SEAS speakers for their time and support.
We took the image of the Sutter's Mill meteorite from NASA's Astronomy Photo of the Day website. We took the image of the rocket from the Little Book of Space Rocks. And we took the image of the scientists searching for meteorites from the article NASA Renews Search for Antarctic Meteorites. Finally, we took the data for the meteorites from the Antarctic Meteorite Classification Database. Thank you for watching.
Now, we would like to take the time to answer any questions.